Very good morning to one and all. So today we are going to discuss about atomic bonding and properties of materials. So we learned about the atomic bonding. We categorized into primary bonding and secondary bonding, and we also discussed what type of bonding exists in materials. And today uh, we are going to continue our discussion. Here we are going to discuss about three important terminologies related to bonding: bonding force, bond energy, and bond length. Here you can see two schematic diagrams. If you look at the schematic diagram, we can see that it's a plot. Look at the first one, I mean the top one, this one. The force versus interatomic distance, or the force. So this plot has been drawn considering two atoms in a solid material. That is, here you can see the on y-axis the force, I mean interatomic force is taken, and on the y-axis you can see the interatomic separation, that is separation between two atoms is taken. Now three curves you can see: one is attractive force, net force, and the repulsive force. Now what this schematic diagram shows is the interdependence of repulsive, attractive, and net forces between two isolated atoms of a material as a function of their interatomic separation. Now, as I explained to you before, let's first assume that one of the atom is in a fixed position and the other atom is taken from infinity and brought towards the fixed atom. I hope you're remembering the case we discussed in previous classes. So, at what happened at larger distances, the interactions between the two atoms are negligible, and hence the force exerted by each other on the other are also negligible. But at closer distances of approach, each atom begins to exert force on other, which means if you are going to take the atom from the larger distances towards closer each other, at closer distances of approach, each atom begins to exert forces on the other. These forces are of two types. One is attractive and repulsive. So that is what is marked here. If you look at the diagram, Fa and Fr, attractive force and repulsive force. You can see here that their magnitude varies with the interatomic separation. So as the distance increases, you can see how the trend, what would be the trend of attractive force and repulsive force. And as it increases or decreases, what would be, I mean the interatomic distance increases or decreases, how the trend changes. Now, what would be the net force? We also discussed about it. The net force between the atoms is a sum of attractive and repulsive components. That is, Fn is equal to Fa plus Fr. That is, as the atoms are brought nearer, I mean very close to each other, assume that it just touches each other. At some distance, separated by two atoms. We always consider the atomic separation as a center to center distance. At the point when it just touches each other, what will happen? The state of equilibrium exists. And that distance, the attractive and repulsive forces balance each other. And the net force would become zero. That is, Fa plus Fr is equal to 0. That is, this point represents. Look at this point. So you can see the net force curve cut the horizontal line at a particular point. At this point, the attractive force plus repulsive force is equal to 0, right? 0. Look at the 0 value corresponding to the net force curve. So you can see that I drawn a line downwards, and you can see the distance marked arrow. What this arrow distance indicates? The distance between the two atoms, center to center distance, at the time when two atoms just touches each other. Maybe I can show you a next image. You can see another image in the next slide, so that you will get a clarity. See, look at this. So here also the same. There is a repulse, so they have marked differently. But you can see the net force curve. See the 0 value and corresponding arrow value. So this is the distance between two atoms that you can see here. So this is the arrow, center to center distance between two atoms. Okay, I hope you are getting. Now, so Here another important information we need to remember is um, another point, because I told you there are attractive forces and repulsive forces between atoms, and the attractive forces that hold the atoms together. Now if you note that the net force curve, look at the top image, the net force curve has a minimum value here. Okay, so this is the minimum value of attractive force, right? Look at this, this is attractive force, and you can see the attractive force and the resultant force are they are same line after this point. You can see that. So this is a minimum value. You can see that the net force curve shows a minimum value. Let us mark this point as Fm of attractive force. So the net force curve shows a minimum value Fm of attractive force, and which means if you want to pull apart the atoms to infinite distance or larger distances, you need to apply a force more than Fm. Then only you will be able to separate it. That is a so Fm will be required. Minimum force Fm will be required. So there's a minimum value of Fm, attractive force, that is required to pull apart the two atoms to larger distances. So and that force Fm is known as the cohesive force that hold the atoms together, or the cohesive strength of the material. You need to apply a force beyond that in order to separate the two atoms to larger distances. Now look at the bottom curve. The same way we plotted, instead of attractive and repulsive forces, the curves are plotted in terms of potential energy. So you can look at the y-axis, potential energy is taken, but you look at the x-axis, interatomic separation, say. So you will get same kind of curves. Okay, you can see repulsive energy, you can see attractive energy, you can see the net energy. So if you observe this diagram, the net energy curve has a trough. Here you can see the net energy curve has a trough, or it is called a well, around its minimum value. This is a minimum value. See, so this minimum value I marked as E0. Okay, that is called the bond energy. The value E0 is known as the bond energy. We already learned about it, right? The minimum energy required to hold the the minimum energy that is required to separate the two atoms to larger distances, that is E0, bond energy. The value E0 in this plot is called the bond energy. So what would be the equilibrium distance correspond? At this condition, the two atoms will be in equilibrium condition, right? You can see this is the point, and you can see the extended vertical line here. So look at the equilibrium distance corresponding to this point. It's nothing but R0. Okay, so the E0 represents the minimum energy that would be required to separate the atoms from their equilibrium distance to infinite distance. So this value of E0 is known as the bond energy, and the distance R0, the distance R0 is called the bond length. That is another important information. There is a center to center distance between two atoms. It's known as the bond length. Okay, so the shape of the curve around E0, the energy curve, net energy curve, the shape of the curve around E0 is called energy well. Energy well. Now the bonds with the larger energy, larger value of E0, and bonds with the lower value of smaller value of E0 is possible, and they are also named in such a way that the bonds with the larger value of E0 are called deep energy well bonds, and bonds with the smaller value of E0 are called shallow energy well bonds. This information is very important. I hope you understand the different aspects. So the bonds with the larger value of E0 are called deep energy well bonds. Bonds with a smaller value of E0 are called shallow energy well bonds. So it depends upon the material, type of materials choosing, type of material you choose. So the energy well values can change. In some materials, the minimum value of energy required is different from the other material. So some materials have deep energy well bonds, some other materials have shallow energy well bonds. Okay, now so this bond force, bond energy and bond length have a lot of influence to the material properties. So this bond force, I hope you understand what is meant by bond length. I hope you understand what is meant by bond force. I hope you understand what you understand by bond energy. All these things, I mean the atomic bonding itself has large impact on material properties. Now, so this is a open book test I told you in the class. I am going to give you this topic. You just go and refer the materials. You can refer it in the textbooks, or you can search it on the online resources, or you can search it on the textbooks. Okay, and the test will be basically this is what I want to get from you: relation of bond length. So today we discuss bond length, bonding force and bond energy, and how this, I mean the entire atomic bonding is related on the properties of materials. For example, atomic radius and bond length, their density, it's a material property. Relation of bond energy with the melting point and boiling temperature. I told you, we just before discussed about the bond energy, isn't it? And we have seen the minimum energy value is zero, corresponding to, I mean that bond energy required to separate the two atoms to infinite distance. And I told you shallow energy well bonds and deep energy well bonds. There are two type of, depending upon the larger and smaller values, or smaller and larger values of bond energy, and whether it has an effect on melting and boiling temperature. So what about the shallow material with the shallow energy well bonds? And what is its melting point, higher or lower? What is the materials having higher energy, deep energy well bonds? What is its melting and boiling temperature, higher or lower? You need to interpret that. And also relation of bond energy with the thermal expansion, isn't it? Some materials expand thermally, you know that. Okay, so when subjected to heat, some materials expand. And does it have any effect on the bond energy and bond length? Does it have any impact? So you need to find out. And also you need to find out the effect on modulus of elasticity. What is modulus of elasticity? All of you know that. It's nothing but the stress by strain. Isn't it? If a material is subjected to an external load, it undergoes a deformation, and the change in length by original length, if it is a the force is acted along an axial direction or linear direction. Strain, how much strain or deformation undergoes for a particular value of stress, that is modulus of elasticity. Does it have any effect on this kind of bond force, bond energy and bond length? Look into it. Strength and thermal and electrical conductivity. So you need to so this is a topic. I will share this slide in your Google Classroom. So we will have an open book test on 23 November, that is on 23 November. Okay, not this date. So be prepared. um, Thank you. Let us meet on 23 November. Thank you.